Imagine Antarctica, a world of endless white, silent and pure. The landscape stretches for miles, untouched and pristine, a place where time seems to stand still. Here, the only sounds are the whisper of the wind and the distant crack of shifting ice. In this frozen expanse, something shocking appears. A glacier seems to bleed. A streak of red cuts through the blue-white ice, as if the continent itself has been wounded. A vivid crimson waterfall pours from the Taylor Glacier, staining the ice with deep red. The color is so intense, it almost looks unreal, as if painted onto the landscape by some unseen hand. This is Blood Falls, a natural wonder that has baffled explorers and scientists for over a century. Its presence is both mesmerizing and unsettling, drawing people from around the world to witness its mystery firsthand. The slow, steady ooze of red water freezes as it hits the air, building a cone of blood-red ice. Each winter, the falls transform, sculpted by the relentless cold into bizarre, otherworldly shapes. When first discovered in 1911, it was a complete enigma. Early explorers could only guess at its origins, their imaginations running wild in the face of such a strange sight. What could create such a phenomenon in a land defined by its lack of color? The stark contrast between the white ice and the deep red water seemed almost supernatural. The red water was so intense, so organic, it seemed impossible to explain. It defied everything scientists thought they knew about Antarctica. The very existence of liquid water in such cold was a puzzle, let alone water the color of blood. How could anything flow in a place so inhospitable, where temperatures rarely rise above freezing? Blood Falls became a legend among polar researchers, a landmark in an already alien landscape. Its story spread, inspiring curiosity and debate in scientific circles and beyond. This crimson enigma flowing silently in the McMurdo Dry Valleys waited for science to catch up. It demanded an answer, challenging generations to solve its riddle, and so began a century-long quest to uncover its secrets, a journey that would reveal not just the story of Blood Falls, but new insights into the hidden world beneath Antarctica's ice. The first explanation for Blood Falls was simple: red algae. Early explorers, seeing the vivid red streaks on the ice, assumed it was a living organism at work. Red algae can color snow elsewhere, so it seemed logical. After all, similar blooms had been seen in other polar regions, turning snow pink or red. But when scientists tested the water, they found no algae at all. The samples were completely devoid of any such life. The mystery deepened. If not algae, then what? The question lingered, puzzling even the most experienced researchers. Some speculated about minerals or red rocks, but the local geology didn't fit. The rocks nearby simply couldn't account for the intense color. Every new theory hit a dead end. Each hypothesis seemed promising, but none could explain the phenomenon. The falls kept its secret, pouring crimson onto the ice, defying explanation. The sight was both haunting and mesmerizing. The extreme Antarctic environment made research difficult, but the allure was irresistible. Scientists braved freezing winds and isolation, drawn by the promise of discovery. Scientists knew the answer had to be extraordinary. Ordinary explanations had failed, so they turned to new ideas and advanced tools. They needed new technology to look beneath the glacier. Only by peering below the surface could they hope to solve the riddle. For decades, Blood Falls remained one of Antarctica's most baffling puzzles. Generations of scientists came and went, each adding a piece to the story. It was a scientific curiosity, a beautiful and frustrating riddle. The falls became a symbol of nature's ability to surprise and confound. The lack of answers only made it more compelling. The unknown drew researchers from around the world, eager to be the one to solve it. Researchers pressed on, determined to solve the mystery. Their persistence would eventually pay off, but not without years of effort. The key would be to see what lay hidden beneath the ice. Only then could the true source of the blood-red water be revealed. The search for answers was just beginning, and the world watched, captivated by the enigma of blood falls. The breakthrough came with ice-penetrating radar. Scientists used radio waves to map the glacier's hidden depths. The data revealed a complex network of channels and fissures, like a secret plumbing system. Blood falls wasn't fed by a small pocket, but by a vast, intricate system. The source: a large subglacial lake, sealed off for possibly millions of years. This ancient lake had been isolated from sunlight and air, hidden beneath the ice. The discovery was monumental, a hidden world beneath the glacier. But new questions emerged. How could water stay liquid in such cold? And what in that ancient water turned it red? The radar had given scientists a target. Now they had to unlock its chemistry and biology. The discovery of the subglacial lake marked a turning point in our understanding of Antarctica's hidden secrets. Beneath the thick, ancient ice, scientists found a world untouched for millennia, a place where time seemed to stand still. Why wasn't this mysterious lake frozen solid like everything else around it? The answer, surprisingly, was salt, lots of it, locked away beneath the glacier. As the glacier advanced over thousands of years, it trapped pockets of ancient seawater. Over time, as the water slowly froze, the remaining liquid became even saltier, concentrating the brine. The result was astonishing: a hypersaline lake, 2 to 3 times saltier than the ocean, hidden deep beneath the ice. This super salty brine acts like a natural antifreeze, preventing the lake from freezing even at temperatures far below zero, defying what we'd expect in such a harsh environment. The lake became a time capsule, perfectly sealed beneath layers of ice for up to 2 million years, preserving ancient water and secrets from a distant past. The water that seeps out at blood falls is more than just a trickle. It's a rare glimpse into this ancient hidden world, carrying clues from a time long before humans walked the earth. The immense pressure from the overlying ice helps keep the water liquid, but it's truly the salt that makes this possible, stopping the water from freezing solid. As the brine slowly oozes out, it freezes on contact with the frigid Antarctic air, building the iconic otherworldly red cone that has fascinated explorers for decades. With this discovery, the mystery of the liquid water beneath the glacier was finally solved, opening a new chapter in polar science. But another question remained: why was the water so intensely red, unlike anything else in Antarctica? The answer lay hidden in the unique chemistry of the ancient brine, where iron and salt combined in a reaction that painted the water a vivid crimson. The final piece of the puzzle was about to be revealed, promising to unlock even more secrets from this frozen ancient world. Scientists analyzed the water and found it rich in iron. The iron comes from the bedrock, dissolved over millions of years in the oxygen-free lake. In this anoxic environment, iron stays dissolved and clear. The transformation happens when the water meets air for the first time in eons. The iron reacts instantly with oxygen, oxidation, forming iron oxide or rust. These tiny rust particles give the water its blood-red color. The glacier isn't bleeding, it's rusting. The mystery was solved. Blood Falls is a rust waterfall, a spectacular display of chemistry. The answer was elegant and simple, but the story wasn't over. The next discovery would be even more astonishing. What else could be hiding in this ancient isolated lake? The search for life began. The falls had one more secret to reveal, and it would change our understanding of life itself. Could anything live in such a place? Dark, cold, salty, and oxygen-free. For years, scientists assumed life was impossible here, but when they sampled the water, they found it teeming with microbes. At least 17 types of microorganisms thrive in this extreme environment. These aren't dormant. They're an active, isolated ecosystem millions of years old. Without sunlight or oxygen, these microbes use a unique metabolism. They breathe minerals using sulfate and iron in a chemical cycle. They are rock breathers, living off the planet's raw chemistry. This self-contained ecosystem recycles nutrients, independent of the world above. The discovery shattered our ideas about where life can exist. Life doesn't always need sunlight or oxygen, just energy and liquid. Blood falls became a model for life in the most unlikely places, and its implications reached far beyond Antarctica. The thriving ecosystem beneath blood falls made scientists look to the stars. If life can exist here, could it survive in similar environments elsewhere? Mars, once wet and now frozen, may have salty, iron-rich aquifers underground. The microbes of blood falls show life could survive there. Even more promising are the icy moons, Europa and Enceladus, with oceans sealed beneath ice. These dark, mineral-rich oceans could host life powered by chemistry, not sunlight. Blood falls is a proof of concept for astrobiologists. It shows that life can thrive in darkness using minerals for energy. When we search for life beyond Earth, we know what to look for. The lessons of blood falls guide our search for life in the cosmos. Blood falls began as a visual mystery, a red stain on white ice. Its story led from mistaken guesses to a hidden lake, to the discovery of life itself. The solution was a tale of chemistry, geology, and time, but the most profound lesson is about life's resilience. Microbes thriving in darkness and salt have expanded our definition of habitability. They show that life's engine can run on the raw chemistry of a planet. Blood falls is more than a curiosity. It's a symbol of persistence. It reminds us to look for life in unexpected places, on Earth and beyond. The falls are a beacon for the search for life elsewhere, and a testament to scientific curiosity. From a bleeding glacier to a model for life on Mars, blood falls reshapes our understanding of our world.